Hello everyone, let's solve the problem number 53, maximum subarray. So what the question states here, we are given an integer array nums. You can clearly see here, we are given an integer array nums, right? So we need to find the maximum possible sum. So we need to find the maximum possible sum of any contiguous subarray. Say they have clearly mentioned here, it should be continual array, right? Or the contiguous array, and it has to return the and we have to return that maximum sum. So what we need to find here, we are given an integer array nums here. You can clearly see one thing. The second thing is we need to find the maximum possible sum of any contiguous subarray, right? So we have to find the maximum possible sum. Just keep this in mind of any contiguous subarray. So we have to go with at any cost. They have strictly mentioned we have to go with the contiguous subarray and we have to return that maximum sum. So that's what they have given here, right? So let's come to the first example here. In this case, so we have this one subarray. This one we are considering 4 minus 1 2 minus 1. So this has the largest sum 6 basically, right? So this we have to return this 6 as output. So if we consider minus this one, if you want to consider 1, we have to consider minus 2. This will be small. If you want to consider this one, minus 4 also we need to consider, right? After considering 1, minus 3 also we need to consider for this one, for this entire one. So first 3 what we will do, we'll ignore this one. We'll start with 4. It will be 4 minus 1 2 1. So again, so to include 4, we have to consider minus 4 here, minus 5 here in this case, right? We cannot go with the minus 5. Minus 5 we cannot consider, right? It will not give the largest sum basically if you consider minus 5. So we'll ignore this one as well. So we are going with the 4 minus 1 2 and 1, which has the largest sum 6, and 6 we need to return output as 6 itself, right? In this case, so this is fine, easy to understand. Let's go with the second example here. Nums equals 1 we have here in this case, right? So only one element we have to we have only one element within the array. We will return the same element. The subarray 1 has the largest sum of 1, so we will return the same element as output. So here in this case, nums we have 5 elements within the nums array, 5 4 minus 1 7 8. So we will sum up this one, 5 4 minus 1 7 and 8. 5 4 minus 1 7 and 8. So this has the largest sum 23. So this has the largest sum 23, right? So this has the largest sum 23. So we will be considering all the elements here in this case, right? So we can consider 7 and 8, minus 1 doesn't matter, right? So in this case, so if or else we have to do only 5 4. If you consider, it will be 9. 5 4 minus 1 7. If you consider, this will also be less than 23. So overall, if we consider this one, all the elements, it will give the largest sum 23 here in this case, right? So we will be considering all the 5 elements within the array, right? So I hope this is clear. They have mentioned, or they have given us wonderful examples just for the sake of understanding, right? So I hope this one, whatever the question they have given, is completely clear, and what we need to do is completely clear as well, the main part. So let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So the first thing that we need to keep in mind is we are going with the greedy approach, greedy plus DP. Basically, we are going with the cadence algorithm, right? So if you don't know cadence algorithm, I have explained the same thing in the algorithms playlist, right? So I have explained using the programming language JavaScript. You can just go through the same thing. So I have explained some of the algorithms, some 20 to 25 algorithms. Within, I think I have explained 23 algorithms. So I can just go through those important algorithms, right? So you'll have the understanding. When we try to solve the problem, you can solve them easily if you know the algorithm. You have already solved them if you would have already solved them, right? So I insist you to go through that playlist, basically algorithms playlist, right? Important algorithms playlist, right? So that is fine. Let's come to the first example here. So I have considered the same example, the first example that they have given in the question, so that it will be easier to understand. In this case, so we have to go with the this one, right? Maximum possible sum of any contiguous subarray, right? Or the continual this one subarray. So here in this case, we went with 4 minus 1 2 and 1, right? This will give us 6 basically. So this we are considering, right? So if we consider any other element that is continually present, it will give us the this one, sum less than 6 itself. So we consider this one, right? So we know this one. We have already discussed this one, right? The 3 examples that they have given in the question, we have already discussed this one. Let's see the step-by-step execution for this one. So here in this case, input we have this one, right? So initially current sum equals max sum equals -2. This one we are considering initially. So current sum and max sum both are -2 initially. Just keep this in mind. This is nothing but the initial part of the initialization. This is fine. So let's go with the calculation part here. Let's go with the calculation part here, right? So I we have considered nums of I, we have considered current sum. So let me give current sum as nothing but in this case, don't get confused while I say current sum. This is max of what it is, max of basically nums of I here, max of nums of I, comma again current sum. This one I'll just write here CS plus nums of I itself, plus nums of I itself in this case. This is fine. So current sum is nothing but max of nums of I here, nums of I, comma current sum plus nums of I, right? Current sum in this case is previous sum, right? So in this case, initial sum we have considered here. Current sum is nothing but the previous result that we got here. This one we will use for this one, current sum here in this case, right? So initially -2, how we use this one? This came from the initialization part. Initially we will consider current sum and max sum. I'll just write ms here. Max sum is -2, current sum is also -2, and the max sum is -2 in this case. So here I we have 1, nums of I we have, I is nothing but the index. So this one 1 2 3 4 5 6 7 8 index, right? 1 based index. So nums of I is 1 -3 4 -1 we have considered, right? So this one 1 -3 4 -1 2 1 -5 and 4. So this starts from basically -2 we have considered initially. The next numbers we are considering this one, 1 -3 4 -1 2 1 -5 and 4. How did this come from? The next elements to -2. This one 1 -3 4 -1 2 1 -5 and 4. This one we are considering, right? So here this is fine. So the first thing here is we have to calculate the maximum. Maximum is max of nums of I. Nums of I is 1 1 -2 the current sum, comma current sum plus nums of I, right? Current sum is -2. So the previous one. So initially we considered -2, right? This one we are considering here as current sum plus nums of I. Again this is 1. So max of 1 comma 1 will be 1 itself in this case, right? Max of 1 comma 1 is 1 itself. So let's come to the second part. Same goes with all the this one, all the rows that is present in the tables. Current sum we are calculating the same way for all these rows basically, right? So here in this case, max of this one, nums of I, we have -3 as nums of I, and we have this one, current sum 1, this one 1 result. So 1 plus 1 plus of -3 is -3, 1 -3 it will be. So it will be -2, right? So this will be -3 comma -2 basically. Max of -3 and -2 will be -2. So maximum sum till now remains same, 1 itself. So same goes with all the things. Max of 4 comma this one -2 plus 4, this is basically 4. Max of and now we have the maximum 4 basically, which is greater than 1. So we'll update this maximum as 4. Max of -1 and this one 3 is 3 basically. We will consider 3 here. In this case, we'll not update the maximum sum because we already have 4. We'll leave this one as 4 itself. Max of 2 comma 5 is 5. So we will update 5, which is greater than 4. Max of 1 comma 6 is 6. We'll update 6 because it is greater than 5. So I hope this is clear. This here maximum, the last column, we are updating only if the value found is greater than the previous value, right? So here in this case, max of -5 and 1 is 1. Will not update anything because we already have the 6 here, right? So last one is max of 4 comma 5. So in this case we have 5. Max of 4 comma 5 is quite obviously 5, and here we already have 6, so we'll not be updating this one with the 5, right? So the last element that we got here is 6. So the last element that we got here is 6 basically. So the last element that we got here is 6. This itself we will be returning as output. this itself we have to return as output, basically return as output. I'll just give here output, right? So what happened here? Output. So the output that we got here is 6. Basically we went with the DP, right? So greedy approach, the maximum we are considering, right? The if it is only maximum, then only we are updating this one in the maximum sum, max sum, right? Quite obviously we are going with the greedy approach here, right? Plus DP. So bottom up, this one we are calculating basically the last cell, the value that is present at the last cell, that itself we will be basically returning as output. So this is cadence algorithm. Basically, if you know the algorithm, you can solve this one very easily, right? So this is cadence algorithm basically. So here in this case, I hope the calculation part is completely clear, easy to understand, right? So this is nothing but current sum we are calculating with this formula, max of nums of I comma this one. CS is nothing but current sum plus nums of I basically, right? So this is fine. So we have returned this one in the form of, so this is fine. I have returned this one, in the form of output, right? So I'll just come here in this case. So let me do one thing. So we have to return 6, right? So here the output that we got here is 6 basically. The output that we got here is 6, the final one, the value that is present at the last cell, right? The output that we got is 6, which is equivalent to the output that they have given for the example 1 in the question. So the approach works absolutely correct in this case. So as we are completely familiar with the approach, let's discuss the edge cases very quickly. So I'll just come here. Yeah. So the first edge case is for the all negative numbers here. So we have all the negative numbers here, right? So output will be quite obviously minus 2. So we have to pick the best, right? So best to pick the maximum single negative number here in this case, right? So we will be going with the minus 2, the largest one. So let's go with the second edge case here, all positive numbers. When I say all positive numbers, 1, 2, 3 we have, right? So we shouldn't be having any negative values here. 1, 2, 3. So entire array is the best subarray in this case, right? We have all the positive numbers, right? So in this case, it will be 6. So let's go with the third edge case here, 1 element. So when I say 1 element, so only one choice we have, nothing but in this case, sorry, this one is not 1 element basically. I wrote wrong, I guess here. In this case, only 1 element we have to consider, right? Let me go with the 4 here in this case. So let the output be 4. So this one I had given wrong elements in the array. Sorry, only 1 element we have 4, and the output will be that element itself, 4 itself, right? So this is fine. So next, let's go with the this one, the fourth edge case, nothing but 0 and negative, 0 and negatives, right? So here in this case we have 0, -1 and -2. So the output will be quite obviously 0. Why the output is 0 here in this case? Because 0 is better than adding negatives. So here 0 is better than adding negatives. When I say 0 is better than adding negatives, so here in this case output will be 0 itself, right? Will be considered, so 0 is quite obviously better than adding negatives, right? So we'll be returning 0 itself, we'll consider 0. So let's go with the fifth edge case here, last element forms maximum subarray. So when I say last element forms maximum subarray, your nums is -1, -2, 10, right? Here in this case we have it starts a new max subarray at the end, right? So this one I'm speaking of, will not be considering this one, it will lead to a negative. So we'll consider only this one. As I have said, it starts a new max subarray at the end. So we will return 10 as output here in this case, right? So 10, we got 10 as output basically. So these are the 5 edge cases that we need to consider. The first edge case is for the all negative numbers. The second edge case is for all positive numbers. The third edge case is for the 1 element, and the fourth edge case is for 0 and negatives, and the fifth edge case is for the last element forms max subarray, right? So these are the 5 edge cases that we need to keep in mind, right? So now we are completely familiar with the edge cases as well as the approach. As we are completely familiar with the both, we are good to write the code, right? So we are good to write the code. Let's start writing the code. So the first thing that we need to do here is we have to initialize both with the first element. Here in this case, I'll give here maxim equals nums of 0, and let me initialize the current sum nums of 0, nothing but the first index. So maxim and current sum both we considered the first element that was present in the array, means first index, 0th index, right? So that one we considered as it was one based index. So the first index we can no, it was not one based index, zero based index itself, right? So the first index, right? So that one we are initializing max sum and current sum to the first index, right? So this is fine. Next, let's start loop from the second element. So I'll just give here for int I equals 1. So this is I less than nums.length. So this will be increment the I here. So within the for loop, what we will do, we will decide to extend or start fresh. Let's decide to extend or start fresh. So I'll just go with current sum here. So here I'll just give math.max of iterated value of the nums current sum less nums of I. This is fine. So within this for loop, the next one is we have to update the global max if needed. So I'll just give here maxsum equals math.max of maxsum comma current sum. This is fine. So this is within the for loop. So this is it for the code. I missed one thing. I think we have to return the maximum subarray sum, right? Finally, so I missed the main part. So here I'll just give return max sum. Sorry, I forgot this one. So let me format this one once and let me hit the run button. So this one we have already seen how we calculated this one, right? So we have already discussed the this one step-by-step calculation part. So this one also maximum sum. So greedy approach we went with. That is the reason we are considering this one max sum, right? The line number 6, pure greedy approach. So here in this case, you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So now let's discuss the complexities for the code that we have written. So the approach that we went with here is cadence algorithm. We know, right? We know this one. So greedy plus dynamic programming, right? So mainly the approach that we went with here is greedy, or we can just say this one as this one cadence algorithm. So the overall time complexity would be big O of n in this case. So the overall time complexity would be big O of n in this case. And what would be the space complexity here? The overall space complexity would be big O of 1 in this case, right? So the overall time complexity would be big O of n, and the space complexity would be big O of 1 in this case, right? So here why it is big O of n here? So because we are making use of the single pass over array which is of size n, and space complexity is big O of 1 because we are making use of only two variables, nothing but current sum and max sum. This one I'm speaking of line number 3. We are making use of only two variables, current sum and max sum. So this we are making use of it regardless of the input size, right? So overall space complexity would be quite obviously big O of 1 in this case. So the time complexity is big O of n and the space complexity is big O of 1 for the code that we have written, right? I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching.